Hello, math students. This is still Module 9, Expressions and Equations, and we are working on Lesson 3. Lesson 3 is called Using the Identity and Inverse to Write Equivalent Expressions. The goal for today we will revisit the identity properties of 0 and 1 and use the inverses to write equivalent expressions. The question that I want you to be thinking about in this lesson is, what happens to the expression when you multiply it by a -1? So some things that you need to know, I believe this should be a review, but they are the official names of properties that we've actually been doing for quite some time. The first one that we're going to talk about is the additive identity property. And basically what additive identity property means, of 0, means is that you are adding 0. And when you add 0, it doesn't change the value of the number that you're adding it to. And so that's one of the things about the identity property. The other thing that you need to be aware of when you are working with the additive identity property of 0 is that you can take a value and you can subtract it by itself, and it gives you that 0 because that's the proof that when you add 0 to something, it doesn't change the value. Well, when you are subtracting the same number itself, you're proving that that 0 quality does have a value of 0. And so let's look at it. We start out with the number 2. We learned in yesterday's lesson, and actually some lessons in our 6th grade material, that subtraction is the same as adding the opposite. So the first thing that we're going to do is we're going to say, okay, we have 2, and we have learned that subtraction is the same as adding the opposite of that value, adding the opposite. So we have to take the value of this, which is a 2, and the opposite of that would be -2. And so now we have 2 plus a -2, and when you look at that, you have 2 positives, 2 negatives, and when you put them together, you get 0, okay? So we are proving the subtraction rule, but we are also proving that when you subtract a number from itself, it gives you a value of 0, because when you add 0 to any value, it doesn't change the value. It remains the same. So let's talk about this one for proof. So we have 4 negatives. We're supposed to take away those 4 negatives. And so by doing that, we remember the rule that subtraction is the same as adding the opposite. What is the opposite of -4? It is a +4. So now we have -4 plus 4. So we have 4 negatives. We have 4 positives, and lo and behold, what gets created when you do that? 0 pairs. And so we've now again proven that when you add 0 to any number, the answer is going to be the number itself. When you take the number self and subtract it from itself, you're going to end up with 0. Okay, so additive identity property of 0. The difference of 5 and 5. So again, this is just writing it in word form. So difference means you subtract, so you're going to set up a subtraction problem. We have the difference of 5 and 5. We know that we have 5 positives. This symbol right here tells us to take away. We're supposed to take away all 5, so if we take them away, what are we left with as an answer? The 0 property again. Okay, this one, we have G, which we don't know, and it says that we're supposed to take away that G, so we're taking it away, and what are we left with? 0. So I've showed it in 2 different ways. I've showed that you could change it from subtraction to adding the opposite, or I've shown you just the pictures of what we're doing, and you see what the additive identity property of 0 is all about. All right, so in culmination of additive identity property of 0, so the sum of a number and its inverse is equal to 0. So that's what we were able to find out. So when you change it to that sum, which is what we did in these examples up here, right, then you notice that it's a sum of the number and its inverse. So we showed that in those 2. All right, multiplicative property of 1, sorry for moving the paper fast. Multiplicative identity property of 1 is very, very similar to additive identity property of 0, except the reason why we use a 1 is that rule that we know that when you take any value and you multiply it by 1, you have the same value. So these are just examples of that rule. And so the way we do this is we can apply the same, technically the same type of property, but the opposite of division is multiplication. And up here, we added the opposite, so down here, we multiply by the reciprocal. So the reciprocal of 3/4 is actually 4/3. So if we take 3/4 times 4/3, we get 12/12, which is equal to 1. So we just proved that when you're multiplying anything by 1, you start out with the same answer, or you end with the same answer. Okay, so let's try this one. Remembering that division is the same thing as multiplying by the reciprocal, well, 4/1 is how you would represent 4, and the reciprocal of that is 1/4. So now I have 4/1 times 1/4 gives me 4/4, which is 1. Okay? And then we're going to do the same thing here. Division is the same as multiplication by the reciprocal, so I'm going to take the reciprocal of 1/9. Then I have 1/9 times 9/1, and I get 9/9, which is the same as 1. Okay? It even works when your values are negative. So remembering that division is the same as multiplying by the reciprocal, so I have a negative 1/3, so the reciprocal of that is negative 3/1. So I take a negative 1/3 times a negative 3/1, and I get a positive, because a negative times a negative is a positive, so I get a positive 3/3, which is 1. Okay? And so we've learned that the product of a number and its multiplicative inverse is equal to 1, and we did that in each instance. Remember, product means that you multiply. So since all of these were division, we changed all of them into multiplication problems. In each area, we changed them into multiplication problems, and you can see that there. Okay? All right, now I have a try this page for you. There's actually 3 problems that you have to try. Okay, so try these. Ooh, you can't see, sorry, that's my fault. So try these. It says, for each problem, find the sum of the 2 expressions. So we're only working with sums, so on your paper, you might want to do this. Okay, and then you have to figure out what the expressions are. All right, so in the first one, it says the opposite of 5x minus 1. Well, remember, you're taking the opposite of everything in here. So what is the opposite of 5x? Negative 5x. What is the opposite of subtracting 1? The opposite of that would be adding the opposite, right? So actually, we have to keep that in here. So if I take that, then I'm going to have subtract a positive 1. So that's inside the parentheses. Sorry, I forgot that I had to do that on the same side. And then it says the opposite of this and this, right? So the opposite of, then you're adding that one. So this opposite only applies to this expression. This and right here means to add, and then that's the other expression. So then you're going to combine those. So technically what we really have is negative 5x minus a positive 1, which is the same as adding a negative 1, plus 5x, right? So I have 5 negative x's, so 1, 2, 3, 4, 5, and I have 5 positive x's, 1, 2, 3, 4, 5, 0 pair, 0 pair, 0 pair, 0 pair, 0 pair, and so those are all zeros, so what is the only thing that I have left? Negative 1. So my final simplified amount of these 2 expressions would be a negative 1. Okay? So then the next one, looking at this one, the reciprocal of 3. So reciprocal of 3 only goes to the 3. You have to figure that one out. And that's what means plus. And then this one. So I'm, again, going to set it up for you, but this time I'm going to make you do it by yourself. Okay? And then this one, same thing. The word and means plus. So you're taking something plus something. So I'm leaving those 2 for you to show me that you can do. Okay? So moving back to our goal very quickly. Today we will revisit the identity property of 0 and 1 and the use of inverses to write equivalent expressions, which we did. We wrote a lot of equivalent expressions. What happens to the expression when you multiply it by a -1? All the values of the expression are their opposites. So if you take a -1 and times it by 2, it now is a -2. If you take a -1 and times it by 6 plus x, then you now have -6 plus -x, okay? So multiplying by a -1 gives you its opposite value. All right, kiddos, that's all I have for you today. I'll talk to you soon. Bye!